Okay, baka hindi po aware ang karamihan sa atin. A Lewis symbol is different from a Lewis structure. So ano ba ang Lewis symbol? So a Lewis symbol is a symbol that represents the nucleus or yung atom that is involved in the chemical bonding. So it presents the core electrons of an atom together with the dots representing the valence electrons or the electrons in the outermost shell of that nucleus. So pakatandaan po, ang isa pong Lewis symbol is comprised of the chemical symbol in the form of, like one or two letters according to the periodic table, and that is decorated by the Lewis dots representing the valence electrons. So magpapakita po tayo mamaya ng maraming examples ng Lewis symbols of different. Okay, so now we're moving on to Lewis structures. Ano nga ba ang Lewis structure? A Lewis structure is a combination of Lewis symbols that represent either the transfer of electrons from one atom to the other, so to form an ionic bond. So we can represent ionic bonds or ionic compounds by combining Lewis symbols. In the same way, we can also represent the sharing of electrons using a combination of Lewis symbols. So again, Lewis structure is the combination of Lewis symbols that represents chemical bonding. So in order for us to effectively and accurately draw Lewis symbols and Lewis structures, we need to have a very good grasp of electronic configuration. So kailangan na iintindihan po talaga natin ang electronic configuration of different elements. At ito muna po ang una nating papracticein. Magre-review muna po tayo ng ng electronic configuration over the next 10 to 15 minutes. Okay, so narito ang ating first set of problems na gagamitin natin para mag-review ng electronic configurations. So, show the electronic configurations for first, hydrogen and helium, and then second, for fluorine, neon, and sodium.
Okay, so bago po tayo tumungo sa malalim na pagtalakay ng Lewis symbols at saka Lewis structures, mahalagang balikan muna natin ang konsepto ng electronic configuration. So magkakaroon lang po tayo ng maiksing review. At magsisimula tayo sa dalawa sa pinakasimpleng elemento sa periodic table. Ito ay ang hydrogen at ang helium. Okay. So, kapag ganito po ang simbolo ng elemento na binigay sa inyo at merong dalawang numero bago yung letter symbol, ano po bang ibig sabihin yan? Yung letter po na nasa baba, that corresponds to the atomic number. Ibig sabihin, yun ang nagbibigay ng bilang ng protons present in that particular element. At alam po natin na kapag neutral ang element, ang number ng protons, which are positively charged subatomic particles, should be equal to the number of electrons. So in the case of hydrogen, kapag po siya ay neutral, kapag since ang kanya atomic number is 1, ibig sabihin po noon, ang kanyang number ng electron is also equal to 1. Meron siyang isang electron. So tatandaan po natin yun. So pangalawa po, yung numero na nasa taas, that corresponds to the atomic mass. So the atomic mass is the sum of the number of protons and neutrons. So dito po, in the case of hydrogen, ang kanyang atomic number is 1. But then its atomic mass is also 1. So that means na wala siyang neutron. So 0 po ang neutron ng hydrogen. That makes it a bit special. So medyo hindi niyo po siya maobserbahan sa iba pang mga elemento sa periodic table. Okay, pagdating naman sa case ng helium. So helium has an atomic number of 2. So ibig sabihin for a neutral helium atom, it has 2 protons and 2 electrons. Pagdating naman po sa atomic mass, it has a value of 4. So from this number, pwede nyo pong tanongin yung estudyante nyo, ilan po ba ang neutrons na meron itong helium? So yung helium should have 4 minus 2, which is equal to 2 neutrons. Kasi again, ang mass number is equal to the sum of protons plus neutrons. Okay, hydrogen has 1 electron, helium has 2 electrons. Okay. At ngayong nabilang na natin ang electrons sa hydrogen at sa helium, at pwede na tayong magbuo or pwede na natin sulatin ang kanyang electronic configuration. Pero bago tayo pumunta doon, recap lang. So, sa lesson po na ito, hindi muna natin babalikan kung bakit ba yung electronic configuration is arranged in a particular manner. So ito muna po, tatanggapin muna na po natin kung ano yung mga tinuro ng mga teachers natin, but meron po tayong ibang session para dyan. So electronic configuration po natin gagamitin ngayon, na which is uniform for all of the elements, would go like this: 1s, 2s, 2p, 3s, 3p. So yung tinuro din sa atin ng mga teachers natin is yung orbital occupancy ng mga ito is 2 electrons sa s orbitals, 2 electrons sa 2s orbitals. Sa 3p orbitals, 6, di ba ang sabi po sa atin? Sa s, 2 rin. Sa p, 6. Bakit ba ganyan yung pagkakasunod-sunod ng orbitals? So kung mapapansin po ninyo, no, ang kada s at p orbital dyan ay merong numerical coefficient. So dito, this is 1, 2, 2, 3, 3. So ano ba yung number na yan? Yung number po na yan, ang tinatawag natin na quantum number. So, ang pinakasimple pong explanation na pwede natin ibigay dyan ay ang numerong iyan ang nagbibigay ng nag-i-indicate ng energy level ng electron. So, ibig sabihin, pag 1, mababa yung energy level niya. Pag mababa ang energy level ng electron, ibig sabihin, mas malapit siya sa nucleus. Mas malakas yung attraction. So, yung 1s orbitals, mas malapit siya sa nucleus. Pagdating ng 2s orbital, mas malayo siya ng konti. And then 2p, and then 3s, and then 3p. So, ibig sabihin yan, kapag palaki na palaki ang quantum number nyo, palayo siya ng palayo from the nucleus. So, ibig sabihin, itong 3p orbital, siya na yung pinakamalayo. So, sa lahat ng orbitals na meron dito, siya ang nakaka-experience ng pinaka-mahinang attraction sa positively charged na nucleus. Bakit positively charged na nucleus? Kasi nandun yung proton. So ngayong alam na natin ang ibig sabihin ng mga numero bago ang orbital. Ang tanong naman ngayon, bakit dalawang electrons lang ang pwedeng ilagay sa 2s? Bakit 6 sa 2p? So ano ang reason behind that? So in reality, 2s mas malapit sa nucleus, yung 2p mas malayo sa nucleus. So, kung i-indicate po natin yung energy level, for example, ng 2s orbitals, and then yung 2p orbital, ganyan po siya, mas mababa yung energy ng 2s kaysa sa 2p. But in reality po, meron tayong 3 p orbitals at the second shell or second quantum number. So, meron tayong 2p, 2p, 2p. Anong pinagkaiba ng mga yan? Magkakaiba lang po sila ng orientation in space. So, isang mahalagang rule po na dapat nating susundin is ang kada orbital ay kaya lang mag-occupy ng 2 electrons. At ang 2 electrons na ito ay merong opposite spin. So, 2s, 2, 2p6. So, ang sabi dito, meron tayong 2 plus 6, 8 electrons na mag-occupy ng second shell. So, in this particular case, ganito po natin siya ipapopulate. So, 1, 2. So, yun yung 2s2. At this is a 2s orbital occupied by 2 electrons. And then 2p6. So, singly occupy muna po natin bago natin i-pair up yung electrons. So, ito po, 3 2p orbitals, each of which has 2 electrons. Kaya po ito ay 2p6. Okay, so klaro po ba? So, ito po yung ibig sabihin nun. So, napakahalaga po, pakitandaan po ito kasi itong electronic configuration na ito at yung orientation ng orbitals in terms of their energy levels, ganito po yung pagkakasunod-sunod niya. So again, pinakamababa ang 1s, then nasa second shell yung 2s at 2p, and between them, mas mababa ang energy ng 2s kaysa sa 2p. Pagdating sa third shell, or sa third quantum number, yung 3s ang mas mababa ang energy at 3p yung mas mataas ang energy. So tatandaan po natin ito. Okay, since na-review na natin yung electronic configuration, gawin na natin ang electronic configuration ng hydrogen at ng helium. Okay, hydrogen. Nagbilang tayo kanina. Ilan ang electrons na meron ang hydrogen? Hydrogen has 1 electron. So kung isusulat natin yung electronic configuration niya, saan tayo magsisimula? Sa 1s. So it's can be 1s, and then yung number ng electrons, 1. So meron pa ba tayong electron na i-distribute? Wala na. And then ano yung maximum occupancy ng 1s orbital dito? 2. So ibig sabihin, sa 1s orbital, meron ka lang isang electron. Okay, tatandaan nyo yan. Now, when it comes to helium, helium has 2 electrons. So, 2 electrons, saan natin siya ilalagay? Ilalagay natin siya sa 1s orbital. So 2 electrons as in the 1s orbital, it will look like this. So 1, 2. Okay, so ang electronic configuration ng helium is 1s2. So ang tanong ko, pwede pa po ba tayo meron pa ba tayong electron na pwedeng ilagdag? Wala na, kasi dalawa na nagamit na natin yung dalawang electrons ng helium. Ang tanong, anong pinagkaiba nito? So itong 1s orbital ng helium is fully filled. So it's completely filled. Hanggang dalawa lang ang pwede niyang i-occupy at meron siyang dalawang electrons. And this is the reason why helium is a very stable element. So it doesn't form compounds. That is because, papakatandaan po natin ito, elements with completely filled orbitals are stable. And yung elements that have partially filled orbitals, they tend to form compounds kasi there is a reason. They would rather have a completely filled orbital. So it's either this might lose its electrons para wala na lang, para blanco na yung kanyang orbital, or it could gain another electron for it to have a stable, or for it to have like a completely filled 1s orbital for it to be stable. Gusto ng ibang mga element maging kaparehas ng electronic configuration ng helium at ng noble gases. But again, tatandaan, stable ang isang elemento kapag ang kanyang mga orbitals ay completely filled. Okay, so pumunta naman po tayo sa medyo mas komplikadong example. So nandito gagawin natin ang electronic configuration ng fluorine, ng neon, at ng sodium. At ang assumption natin dito, these are all neutral elements. So, atin munang suriin. So, fluorine has an atomic number of 9. So, ibig sabihin, for a neutral atom, it should have 9 protons and 9 electrons. So, for fluorine, it has 9 electrons. For neon, it has an atomic number of 10. So, therefore, for a neutral element, 10 protons and then 10 electrons. So, 10 electrons for neon. Pagdating naman sa sodium, it has an atomic number of 11. Again, neutral element, 11 protons is equal to 11 electrons. So, ito yung mga gagamitin natin bilang ng electrons sa electronic configuration. So, gawin naman natin ngayon ang electronic configuration ng fluorine. So, gagawin natin 1s2, 2s2. So, ilan na nagamit natin dyan? 4. And then, the next orbital that we will have to occupy will be the 2p orbital. Na ilan ang total occupancy ng 2p orbitals? It should have a maximum of 6 electrons. Again, kasi tatlong 2p orbitals. 2 electrons each. So, ilan pa natitira nating electrons? So, 9 minus 4 leaves us with 5 more electrons. So, therefore, pwede pa natin siyang ilagay dito. So, but, tanong lang po sa inyo, na-occupy ba natin ng completely ang orbitals ng, ang 2p orbitals ng fluorine? Ang sagot po ay hindi. So, meron ka dyang vacancy. Kasi maximum niya is 6. Pagdating naman sa neon, this is how we're gonna do electronic configuration. So, 1s2, 2s2. So, nakagamit na tayo ng 4 electrons. 4 minus 10 is equal to 6 electrons. So, meron pa tayong 6 electrons na pwedeng ilagay. Ngayon, ang next orbital is a 2p orbital and it can occupy a total of 6 electrons. So, therefore, ito, puno na siya. So, this is a completely filled electronic configuration. Up until the second energy level, puno lahat ng electrons. Pagdating naman sa sodium, ang electronic configuration niya should be 1, S2, 2, S2, and then so 4 na yung nagamit natin, minus, so 11 minus 4 electrons, meron tayong excess of 7 electrons. Pero, doon sa 7 na yun, 6 lang yung pwede natin ilagay sa 2p orbital. So therefore, kailangan natin umakyat ng isa pang energy level, which is a 3s orbital, at doon natin ilalagay yung pang 11 na electron. Okay, ngayong natapos na natin ang electronic configuration ng fluorine, ng neon at ng sodium, meron tayong mga babalikang ilang mahahalagang konseptong pinag-usapan natin kanina sa case ng helium at saka ng hydrogen. So, sabi ko kanina, ang electronic configuration of neon is very special kasi lahat ng orbitals involved are fully occupied. So, for example, dun sa first energy level or quantum number na 1, where we only have 1s orbital, fully occupied, dalawa. Doon naman sa second shell, we have the 2s and the 2p orbital. The second shell can occupy a total of 8 electrons. So in this case, how many electrons do we have? 2 plus 6 is equal to 8 electrons. So, Itong configuration na to is the reason why, like helium, neon is a very stable element. So it doesn't form any chemical bonds, it doesn't form any compound because it has completely filled orbital. And in this particular case, may dalawang mahalagang concept akong ituturo sa inyo. Ano ang tawag natin sa 1s orbital? So yung 1s orbital, which is situated or which is contained within the first shell o yung mas mababang energy level or mas malapit siya sa nucleus ng neon, this is what we call a core orbital. So this is the core orbital. And inside the core orbitals are what we call the core electrons or the inner shell electrons. Ang tawag naman natin sa mga electrons na nasa highest energy level or nasa highest quantum number are what we call the valence electron. So, yung valence electrons ay nakapaloob sa tinatawag nating valence orbitals. At gaya nga ng sinabi ng Lewis theory, elements form chemical bonds or they form compounds in order for them to have a stable configuration. And the stable configuration na sinasabi natin in this particular case would be a complete octet of electrons at the valence shell. So, kailangan yung nandun sa valence shell ay merong 8 electrons. So, completely filled ang 2s at ang 2p orbital. So, kung ang valence shell naman natin nasa third quantum number, dapat yung 3s at 3p ay merong total of 8 electrons. So, that is what we call the octet rule. In this particular case, sodium, may tendency siya na mag-form ng sodium plus ion. Kasi when you form sodium plus ion, that means it lost 1 electron. So, pag nawala na tong electron na to, what you're left with is an electronic configuration for sodium plus ion. And kung mapapansin niyo, ang sodium plus ion has the same electronic configuration as neon, which is a stable configuration. Again, bakit? Because now its valence shell include the 2s and the 2p orbital na merong 8 electrons. So it's the octet rule. Pagdating naman sa fluorine, once it gains 1 electron, it becomes what we call the fluoride ion. So the fluoride ion gains 1 electron and in the process, 5 plus 1, magiging 2p6 na to. So therefore, ang electronic configuration ng fluorine becomes equivalent to the electronic configuration of neon. So again, nagbabago ang bilang ng electrons dito sa mga elements na ito when they form compounds in order for them to achieve a complete octet. Kasi again, pag may octet, stable. So again, idol ng fluorine at saka ng sodium ang neon. So therefore, kokopyahin nila sila by either accepting an electron or by donating 1 electron.